Good morning, guys. Today we're going to start off by looking at Chapter 7, the first lesson. And in this chapter, we're going to be talking about arrays and the array list class. Now, we can have one-dimensional arrays, two-dimensional arrays, multi-dimensional arrays, but in this chapter, we're only going to concern ourselves mostly with one- and two-dimensional arrays. We will mention and just very briefly talk about what a multi-dimensional array is. And we'll also be talking about the array list class. This is a large chapter. There's a lot of stuff in it, so there's no sense in us getting ahead of ourselves. We're just going to start off today with the introduction to arrays. Now, as you can see here, these are the chapter topics. I'll let you read through your textbook or through the notes to look at a list of everything that we're going to be talking about in this chapter, but here to begin with, we're just going to be introducing arrays. So I'll let you read through these lists of topics. All right, now the main concept of this first section is what an array is and what it does. So an array can hold multiple values of the same data type simultaneously. And again, simultaneously means at the same time. Now notice in there we said it can hold multiple values of the same data type. Multiple means as many as you want, but it has to be of the same data type. So if you wanted to create an array that would hold integers, then every value that you would put in this array has to be an integer. You cannot mix data types. Now, primitive variables are designed to hold only one value at a time. Think back whenever we declared a primitive variable. For example, let's say hours. We would say int hours equals 40. So that variable hours was only designed to hold one value at a time. Now, an array allows us to create a collection of like values that are indexed. Now, what indexed means is it just gives it a subscript, a name, so that you can identify it more easily. Think back to your Algebra 1 class whenever you worked with a matrix, like a 3 by 4 matrix. A 3 by 4 matrix means that it had 3 rows and 4 columns. So if I said, look at element 1, 0, that would mean go to row 1, column 0. So they're just saying that they're indexed. It's very easy, and we're going to look at that here today. So think of your arrays as a matrix. But here in the beginning, when we talk about a one-dimensional array, it only has one row. Now, an array can store any data type of data, but only one type of data at a time. We already said it can only do one at a time, but it can hold any type of data. So it can hold integers, doubles, floats, bytes, longs, characters, strings. It can hold any of them, but only one data type at a time. And an array list, or an array, is simply a list of data elements. We're going to see that. All right, first of all, how do we create an array? An array is an object, so think back the difference between what a variable is and an object. An array is an object, so it needs an object reference. So again, we're going to be using the new keyword. So here in this first example, we're going to declare a reference to an array that will hold integers. So we start off with the type of data that the array is going to hold. Now we can see here that we have int. So that means the array that I'm going to create can only hold integers. So if you try to store anything other than an integer in it, you're going to get an error. Now this little symbol here, the open bracket and close bracket, represents a one-dimensional array in Java. Now this bracket could come before the variable name or it could come after the variable name. It doesn't matter, but in convention, most of the time you're going to see it immediately appear right after the data type that it's going to hold. So we have the data type, we have the open and closed brackets representing a 1D array, and then we have the array name. Now this first statement here, all it did was declare a one-dimensional array. It did not create a one-dimensional array because again, we said arrays are objects. Objects have to be created and they are created with the new keyword. So since we didn't use the new keyword here or put any values into the array, we're going to talk about that in a moment. We didn't create anything, we only declared. All right, now the next step creates the array and it assigns its address, because remember, it's an object reference, it assigns its address to the numbers variable. So now that we have declared it up here, we already did the declaration, we can now in a new line say numbers equals new. Here we are, we're now creating the array. int, notice the word that int gets repeated, the data type gets repeated just like when we declared any other object. And inside these little brackets that follow, we are going to put how large the array is. In other words, how many elements do we want this array to hold? And this is called the size declarator. Now, we don't have to fill the array all the way up because by default it will put some zeros in there. We'll talk about that in a moment. But we definitely could not go any larger than 6 elements. So if we created an array that can hold 6 elements, we may go in and put 4 elements in it, and that is fine, but we wouldn't be able to put 7 elements in it because that's larger than what the array can hold. Alrighty, so let's look at this array. We said that we created an array of size 6, meaning to hold 6 elements. So right there, as soon as you create the array, that is what it would look like. This is a one-dimensional array, meaning one row. And when you create it, by default, it will fill all of the elements in the array with whatever its data type is. Now here, first of all, we're talking about an integer, so by default, it filled it with zeros. All right, now let's talk about the names of these cells. We said on the previous slide that arrays are indexed by name. Arrays always start at index 0. Index 1, index 2, index 3, index 4, and index 5. Now we said that the array is size 6. Where'd my cursor go? Size 6, but the indices only go up to 5 because we start at 0. But we can see here that we still have 6 pieces of information. There's 1, 2, 3, 4, 5, and 6. So it still is size 6, but the indices go from 0 to 5. So array elements are initialized to 0, and array indices always start at 0. They always start at 0. Now it is possible to declare an array reference and create it in the same statement. Now we have done that before with objects of classes where we declared them in one statement, created it in a second statement, or we can declare them and create them all in the same statement. So let's look at the last example, but all put together in one statement. Here we declared an integer array, an integer one-dimensional array called numbers, and then we use the new keyword to go ahead and create it, and then we set it to size 6. We did it all in one statement. As we said before, arrays can be of any data type. Here, let's look. We have a float called temperatures, new float, and we set it to size 100. Now we set this to size 100. What would the indice range be? It'll start at 0 and go all the way up to 99, but that will still hold 100 pieces of data, 100 elements. Here we have a character one-dimensional array called letters equals new char, and we set it to size 41. Again, what would the indices be? They would be from 0 to 40. Here we have an example of a long one-dimensional array called units equals new long, and here we set the size of this array to be 50. So what would the indices be? 0 to 49. And again, we have a double one-dimensional array, an array that will hold doubles called sizes. We created it with a new keyword, and we set the size here to 1200. What would the indice range be here? It would, again, they always start at 0, and it goes clear up to whatever the length of the array is minus 1. So here we would have 0 all the way up to 1199. Now, when you set your array size, whenever you create the array object, it must be a non-negative number. So as the size declarator, you can't put in a negative number, and you wouldn't put in a 0 either. Putting in a 0 would mean that you're trying to create an array that doesn't hold any elements, which doesn't make sense. Now, it can be a literal value. Now, when we say a literal value, we mean actually putting a number in it, just like we did in the last example when we put a 6 in it. It can be a constant, a named constant like we're going to look at below, or we can put a variable in it. We can pass by variable. So let's look at an example here. Let's say that we had a named constant called array size that is of type int. and we set it equal to 6. Then we came down here and we created a one-dimensional array that's going to hold integers called numbers. We created that array, but instead of inside these brackets where the size declarator is, instead of putting in an actual value, we passed by variable. We passed the array size variable into here. Well, array size holds a 6, so when you create this array, it actually is creating an array of size 6. Now, once the array is created, the array size is fixed. It cannot be changed. You cannot shorten it. You cannot make it longer. If for some reason you realize that you made a mistake and you need an array that will hold more data values, you just have to create a new array because you cannot modify this once it is created. All right, how do we access the elements of an array? So let's say that we have this array. It's a 1D array of size 6. And sitting in the first element, we have the value 20. So an array is accessed by its reference name. Okay, we said arrays are objects, so they have references. So that is why it's important for us to have an index so that we know what we're talking about, so that we can identify which value in the array that we want. So if I said, tell me where the number value 20 is located, you would say at index 0. Okay, so it's just a subscript that identifies which element in the array to access. We're going to look at a short program here in a moment. But this statement here will store the value 20 in the first element. Now, the first thing we have to do is call upon the name of the array, because if I had several arrays and I said, store this value in the array, the first question you would ask me is, which array do you want me to store it in? So I have to give you the name of the array. All right. I always lose my cursor. All righty. So I say, go to array called numbers, and in index 0 or subscript 0, I want you to set that value equal to 20. So when this array was created up here, first of all, as we saw in the last slides, by default, all of these numbers in here were zeros. But when we write this statement here and I say go to array called numbers at index 0 and set it equal to 20, it comes up here at index 0, which is the first element in the array, and it changes that value to 20. So pretty simple. Now, array elements can be treated just like any other variable that we have been using. They are simply accessed by the same name and the subscript, whichever one you want to access. Now let's look at the example called Array Demo 1 on page 408. All right. So here we at the very first statement, we are using our Java utility scanner so that we can get some information from the user. And it says this program shows values being stored in an array's elements and going to be displayed. All right, so this stuff here is all normal. You understand this. We're in the runner program. This is a client program that has the main method header. We can see here on line 12 that we have a named constant. We said final int employees because we're going to store information about our employees. And then in line 13, we can see here that we are creating a one-dimensional array that will hold integers, and its name is hours, equals new int. And we can see here in the size declarator when we created this 1D array that we are passing by variable. Now, since up here we have our named constant called employees that is set equal to 3, and then we pass by variable right here, this makes our 1D array of length 3. That means it will hold 3 elements. All right, in line 16, we're going to create ourselves a scanner object so that we can get information from the user. And then on line 18, we prompt the user. We say, enter the hours worked by employees, and then whatever the employee number is. So here we go, line 22. We're not going to use a loop in this example. We'll look at a loop in the next example. So each time we're going to have to prompt the user with a new print statement. So line 21 says get the hours worked by employee 1, and then system.out.print employee 1, and then right here the user is going to be entering in information. Well, when the user enters information, we have to have some place to store it. Well, if I'm talking about the first employee, it will be stored in index 0. So we call upon the matrix or the array that we're looking at, and we tell it which position to store it in. Well, since this is employee 1, we're going to store it in position 0. So hours index 0 will store whatever the user enters in. Now, since we are going to get information on 3 employees, we're going to do this 3 times. So again, on line 26, we say employee number 2. The user will enter in how many hours worked by employee 2, and it will store it in hours index 1 because that is where the second employee's information will be kept. And then we're going to do the same thing for employee 3. We ask the user to enter in the hours for employee 3, and it gets stored in the array hours at index 2. So the length of our array was 3, and we have had the user enter in pieces of information for all 3 employees. Now we can go and display our information just the same way using an index. So on lines 34 through 37, we say here the hours you entered are, and then notice here on line 35, we call upon the array and we call upon which index we want to be printed. And you can see down here, it'll say employee 1, okay? Well, this is where the user entered information. Line 35 actually says just print whatever is stored in hours at subscript 0. Well, that was the information for employee 1, and the user entered in 40 hours. And so it's very easy to go in and access the elements of their array as well. All right, let's look at a second program. Now, this program is the exact same as the last one we looked at, but instead of asking the user to enter the information, calling them with print statements one at a time, we're going to use that information in a loop. So you can see that the first part of this doesn't change. It's the exact same thing as the last one. Here on line 12, we created a one-dimensional array, and we sent it employees, the value stored in employees, which is our size declarator here of 3 employees. Again, we created ourselves a scanner object, and we are now prompting the user to enter in information for these employees. But instead of printing that information 3 times, we're going to put it into a loop. So now this is really important because you want to make sure that you don't get what's called an index out of bounds error. Now, before we get started here, we have to ask ourselves, how long is our array? Well, we know that our array only holds 3 pieces of information, and its indices range from 0 to 2. When you start your index at 0, the length of the array is always the array size minus 1. So let's look at our loop header here. So we say for int index, we're starting at element 0, which is the first element in our array. And then we will continue this loop all the way up until index is less than employees. Well, remember, what is stored in employees? There is a 3 in here. So as long as the index is less than 3, we will continue this loop. And then, of course, this is our update section, which will increment it each time. So if we start at 0 and we continue up to index is less than employees, that means index is less than 3, how many times will this loop iterate? It'll iterate when the index is 0. It'll iterate when the index is 1. It'll iterate when the index is 2. But whenever the index is now a 3, the index is not less than 3, the index is equal to 3, so the loop will terminate. It will exit out. If you tried to have it loop through more times than the length of the array, you will get an index out of bounds array. And that's what we'll look at in a moment. But let's look at our loop. We can see here that on line 23, we prompt the user and we say employee. Now, again, we've used this notation right here before where we say index plus 1. We don't want to say employee 0. That wouldn't make sense. So we take the index that we're using right here and we just say plus 1 because 0 plus 1 is 1. So that would be employee 1. And then again, we use the keyboard.next int, and it gets stored in hours at whatever the index is. And since we're starting the index at 0, it'll put it in as the first element. So it is the exact same thing as the last program, except for it prompts the user and gets the information in the form of a loop. And you can look at the program output below and you see that it's the same. All right, so just to recap, the index here, when you in your for loop, it starts at 0. Always start at 0 because your arrays are starting at 0. And then it's always your index is less than, not less than or equal to. Please do not put a less than or equal to here, because if you start at 0, this has to be less than. If you start at index 1, well, then you're going to miss the first element in your array. Okay? Now, index out of bounds array checking. Like I said, they always start at 0 and they continue to your array length minus 1. Please don't put less than or equal to in there, or you'll get an index out of bounds error. And Java does not allow a statement to use a subscript that is outside the range of valid subscripts for an array. So be careful of that. And this would be a runtime error. It would not be a compilation error. So if you were trying to access elements of an array that doesn't exist, it wouldn't give you the error until you actually executed the program. It wouldn't give you the error when you're compiling. Okay, so let's look at an example of that. It says this program uses an invalid subscript with an array. So here we go. We created our 1D array called values, and we set it to size 3. And it says, now I'll attempt to store 4 numbers in this 3-element array. So let's look at our loop here. Everything is good. We start off with our index at 0, but this time we say index less than 4. Now we can only see up here that our array is only size 3. That means it can only hold 3 numbers. But if we start at 0 and go through the loop, that's once. Then it becomes a 1, that would be twice. Then it becomes a 2, that would be 3 times. Then it becomes a 3, that would be 4 times. And we don't have an array that is large enough for that. Okay, so we have to be careful that we don't have an index out of bounds of error. So it's very easy to be off by 1 whenever accessing arrays. So I am recommending that you be very, very careful whenever you use loops and use variable names, but you don't have to just use variable names. You can actually put numbers in there, but you leave yourself open for errors when you actually put numbers in your update section right here. Okay, so says this code here has an off by 1 error, meaning an index out of bounds error. So here we create an 1D integer array called numbers, and we set its size declarator to 100. That means that this array will hold 100 integers. So we come to our loop, but notice what's going on here. We start our I equals 1, and then we say as long as I is less than or equal to 100. Okay. And then we say numbers I equals 99. Well, what's this statement right here going to do? This says that numbers index I equals 99. Now the intent of this code is to create an array of 100 elements, but the indexes are 0 to 99. By starting your index, your I, at 1, which is the first subscript is skipped. That means whatever's stored in the first element. It got skipped, and we're starting actually at the second element in the array. So what it's going to try to do, it's going to try to store 100 elements in this array, which is size 100, but because you skipped the first element, it is going to be trying to store a value that is just outside the bounds of the array. So here the equal sign allows the loop to continue on to the index 100, but there is no such index 100 because whenever you set the size of the array to be 100, its indices are 0 and 99. And here it's trying to store the value 99 in index 100, and it doesn't exist. All right, we're going to stop right there, and you will be able to go and do your checkpoint questions for lesson 7.1. And if you have any questions, please make sure that you leave a comment or email me.